Sorry about that. I had to set some stuff up. What's up?
Um, I was wondering, are we allowed to ask questions about the exam, the
Yeah,
past
sure.
test?
What
Um,
specifically?
I was wondering for the second problem, the last part, for calculating, yeah, the distance away that the hippo needs to stand to
Hmm.
get the water in its mouth. I was wondering, I just like kind of blanked on that one and went back to like kinematics one stuff, just kind of did like a found how long it would take for the water to fall 8 meters if it was like an object, and I didn't know
Yeah.
if that was the right
No,
thing to
yeah,
do.
that's exactly what you're supposed to do.
Okay.
Yeah, you can basically treat the water like as essentially just a continue like a bunch of objects.
Yeah.
So it's going to follow the same laws of physics. You do the same kinematic stuff. I'm
Okay.
pretty sure there should have been one of the questions where that kind of had a projectile stuff, but even still, that's actually something that is just a typical question that kind of you should all kind of remember how to use the kinematics
Yeah.
equations. It's like the standard stuff.
Okay. So yeah, I was thinking like I don't think water should fall that differently from a ball or
Hmm.
something. So um yeah, that was the only one I was unsure on, but if I got that right, then I don't actually know where I lost points.
Well, one I don't know specifically about
Yeah,
people, but
sure.
one thing I was gonna say is one issue that I saw a lot was well, first off, there was an issue on problem two with a
Hmm.
lot of people incorporating the atmospheric pressure when you do the equation. So when you go to find I believe it's the force on the spigot,
Yeah.
you're supposed to do the gauge pressure because on the water side of the spigot, there is the absolute pressure is the atmospheric pressure plus the gauge pressure from the water. But on the other side, you have an equal amount of atmospheric pressure. So the
Hmm.
difference in pressure is the gauge pressure. So a lot of
Okay.
people weren't doing that. So that was a point off. Um, Another issue I kept seeing was I had told people that you had to make sure that you start with the generic equation and then you have to kind of explain or prove why you might go with a more specific equation. For
Yeah.
example, 2b, you had to start with Bernoulli's equation and
Right.
then show why you can use Torricelli's. You couldn't just go straight to Torricelli because Torricelli uses a lot of um, what was the I didn't want to say estimations, but
Like
a lot of
assumptions.
yeah. Okay, there you go. It uses assumptions that you need to clarify, and I just wanted to make sure because, like I said, while it might have worked there, there's a lot of times where people will just use an equation without it actually fitting the scenario. So
Sure.
you want to get into the habit of knowing first off where's that equation coming from. What is the root of that equation? It's Bernoulli's, and then show me that you understand why we can use it because the
Yeah.
pressures are equal on both sides and the velocity at the top is zero. So that was like another issue that people were having. There were some issues with people either forgetting units at the very end. You didn't have to put units in the substitution, just at the
Yeah.
very answer. So this actually was especially important because some people would convert the um, distance or the diameter from question one. Some of them converted into meters, but didn't actually put the meters unit. So, like, how am I supposed to know what unit that's in? Because
Yeah.
some people gave the answer in millimeters, centimeters, meters. So that one was especially something that you had to make sure that you showed work for,
Sure.
or sorry, the unit for. Um, sorry. Uh, and then there was another issue. There was also the typical issue of some people putting wrong numbers, like the height difference. People weren't putting the height difference in for the water question.
Mhm.
Um, it's just small things like that. Um, yeah.
Could I also ask, if we can't get like individual feedback on questions, could you at least publish like like I think you said it was curved, and I was just wondering if you could give us like stats for the test so we know how well we're doing respectively, just by our
So,
number.
all right. So, well, the test. the test was curved, but the thing is, a lot of the people at the high end didn't actually. There was a lot of people who got high grades on it, so there actually wasn't that much of a curve. The curve actually only applied for the people at the low end.
Mm,
So anyone who got less than a 70 were the only ones who actually got curved.
okay.
So like some people who got 65s or 60s, it kind of curved them a few points up. Anyone who got below a 50 just got curved to a 50 since that's basically
Mhm,
bare minimum. The way I do my curves is I actually set it to I do percentages for letter grades. So that's why 50, like the lowest that you can get is a 50, because the lowest you could get is an F, which is curved to a 50. Um, so yeah, certain percentage of people go into the different groups. So
mhm.
unfortunately, the people who get lowest in the lowest ranking ended up getting a F, which I think there was only like two people like that. And
Mhm.
then there were a few 50s. I think the average ended up being like a mid to high 70s.
All right. And there's no way we can tell where we lost the points, like which question.
Yeah, I was so I used to do it for Blackboard where I actually had the questions broken down and then I would kind of tell you where the points were,
Yeah.
but I that's just it takes a lot of time. Especially with the number of people I have in the class. I
Mhm.
was thinking about at least giving you points for per part. Question one, you
Yeah.
got this number of points. I'll have to see how much time I have on hand today, since,
Sure.
as you guys know, I didn't get them graded until late Saturday, early Sunday. Uh, I'm trying to get them graded as quickly as I can, but unfortunately, with the number of people there are and
Yeah.
uh, still having my actual job, it gets a little bit time consuming.
Sure. Um, and you can't publish like a rubric or a solutions guide just because of have people not taken it yet or something.
Yeah, I mean, I can kind of quickly go through roughly what you would do. I can't really say I won't say the answers, um, but I can do a kind of a rough draft of what you're supposed to do and what yeah, just a quick idea of like what you're supposed to do and anything that I saw in each part that people might have made mistakes on. All right. So you know what? Give me 1 second. All right. So for question one, that was actually just a straightforward sum of the torques type question. So realistically, it just should have been torque coming from the cable plus um, torque coming. Shouldn't be plus minus torque coming from the beam minus torque coming from the sine. The only thing that you had to note was that the cable, um, the angle was given from the vertical. So I think that angle was 75 degrees. And you had to actually make sure that if you were going to do FR sine theta, that the theta was sine something. Some people did instead use cosine. That's actually perfectly fine. So they ended up still using like cosine of 75 and kind of had things flipped. Perfectly fine. But basically, you had to be careful with the angle for that one. So some people got points off because of that. Um, and then that was part A. Part B, part B and part C, we're just using some of the forces. Some of the forces in the x direction, some of the forces in the y direction. For the most part, I think most people ended up getting those. Like I said, I don't hit you guys with double jeopardy. So if you ended up getting the answer wrong up here, I did make sure that it made sense with the follow through, as long as you had the angles correct. Uh, the only thing I could think of here is that some people weren't plugging in their numbers. While obviously, with from my experience, I can kind of figure out what you're doing, but I do want to see the setup equation, numbers getting plugged in, and then an answer, because sometimes it's hard for me to tell what numbers you're actually using, especially if you ended up getting part A wrong. So there are some times where people were getting part A wrong, and then when they went to part B, I didn't know what of the numbers they got from part A were being plugged in because they didn't show me. So part B was also wrong. And that made it even more difficult since I had to actually go through all the different variables to see which one they actually use to test it, because they would, they would do some of the torques. They didn't use the sine theta part, so they were solving for the y component. And then some of them, I think there was one person who like found the sine component, used tangent to find the cosine component, then did Pythagorean theorem to find the main one. So then when they went to calculate the x component, I couldn't tell which of the three numbers they used. So that's why it's very important that you show me, the next line being, if you did force of the hinge in the x direction equals the force from the cable in the x direction, and then say this is 500 cosine 30 or whatever it was. Like, this is what I need to see, because I want to be able to say, okay, I see where the number is coming down here. It's all about allowing me the ability to look at it quickly and check for validity, rather than having to go through and almost do the calculation for you to see whether or not you made the correct choices. That's why it's important that you show the substitution. I should also point out that even if you get the answer right, I still want to see that, because I'm also trying to prepare you guys for just good practice skills. Because when you get further in, there are going to be a lot of times where you're going to have to review your notes, or someone else is going to review your notes, and you need to make sure you can follow through what you're doing. And if you just write like a base equation and then the answer right away, and there's no substitution of numbers, there's no indication of what numbers you're actually using, you're not going to have a good time at understanding what's going on. So that's kind of why I'm trying to hit this, is because this is good practice. This is good uh, skills to be able to do, is, you know, showing the work a little bit more than just equation and answer. All right, so that was that. I didn't really see any, I don't think I saw any issues with why that wasn't similar to X, part B. Part D, you basically had to do the strength. There really wasn't like an official equation for symbols, at least. At least I don't think I gave one. It's just strength equals force over area. And you use this. The biggest thing that I saw here, some people are using a slightly altered equation where they're using, like, I think it was the G delta L over L um, equals F over A. And yeah, that's sort of the equation, but they were using the 500 number in for G. So it ended up kind of throwing things off. That was one issue I saw with this. The other issue were people solving for the radius and not the diameter. Um, so that's another thing that you want to look out for. Um, E was decrease. So the only thing I saw here, there were two ways that you could have explained your work. One of them was by showing the answer algebraically, or like taking the torque and getting it all the way down to the part where you actually have it as force from the hinge or wire. I forgot exactly which one it was. Equal to blah 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 blah, all the other variables. Um, Getting it to that point and then saying, if this variable changed, if R decreases, therefore this also decreases. So that was one way. The other way was to mention about how decreasing the torque decreases the torque. The only the only ones that I saw that I didn't give credit for were people who only said, if you decrease the distance, you decrease the force, because that just kind of reiterates what the question was asking. Like, the question was asking what happens to the force, and if you say it decreases because when you decrease one, you decrease the other, like, that's not really proving the relationship. You're just kind of saying it. I mean, I could say the same thing if you want to know, if I decrease wheel size, what happens to speed? And I say, oh, decrease the wheel size decreases the speed because decreasing decreases. Like, okay, but there's no other reason behind what I just said. So that's why you have to do something. You have to either mention the concept of torques because that gives that relationship that the torques on both sides, like the torques have to be equal on both sides. So because of the equation, there's an inverse relationship between force and distance. That okay, that makes sense. Or you could say something like, or sorry, not force and um, torque and distance. There's a direct relationship between them. So decreasing the distance decreases the torque. Therefore, same applies to the cable. Or by giving the equation and showing like this is why I'm doing it. All right. Does that make sense? All right. And then besides that, there was also question two. Question two was multiple things. That was where you had to kind of do force equals um, force over area equals pressure. There were some people that I did actually notice that they, I'm pretty sure I gave this warning in the video. I can't remember, but you want to be careful with your symbols, especially with this. It's the rho and the P look very similar. So a lot of people wrote F equals PA, and I think they misread what they wrote and thought this was a rho. So that's actually why you try to really differentiate the row with your P, because I saw some people set it up, but plug the wrong thing in. And like I said, the big key thing here was that this pressure wasn't absolute; it was atmospheric. Um, and then I kind of already went through B and C, so I don't think I really need to go over those in detail. Once again, B you had to use Bernoulli's, and then explain or prove or like a little blurb explaining why you can kind of get it to Torricelli's or at least show it, show the Torricelli derivation. And then part C, as you said, treat it like a projectile, use kinematics, find the time it takes to fall, find the distance, bada bing, bada. Did that answer your question?
Thank you. Yeah.
All right. Was there any other questions? I know one person had asked about going over the questions. I think I answered that question. So is there anyone else who had something?
I have a small question. I think for you said problem one, part E, you said that we had to explain why it decreased. If I mentioned that, if I mentioned that T was proportional to the distance based on the derivation from part A, and that's the reason why it decreases, would that work? Or did I
Yeah,
get
that
points off for that?
that should have worked because it does kind of go back to saying that you're at least like showing the equation, even if you say looking back at part A, as long as there was a part in A where you kind of had the some of the variables in there. I'm trying to think of like a good example of that. Okay, so I guess there were some people who, when they did their answer for part A, instead of writing it out completely, or they might have said like the sum of the torques equals 0, and then immediately jump to saying um, force in the y times I forgot what the distance was. I think it was 1.5, and then they had the full answer of like 3,000 plus 250, and then like based on like if you did this, I don't know where that r is. I don't know where r for the signs distances. But if you had broken it up like this, um, and then it was 250 times 10 times whatever, and you had it kind of separated, or better yet if you had it written like this, and then it was you would have done length of the cable equals fg of the beam, length of the beam. If you did something like this, then it's definitely very clear. You know, this is the term that you're saying. If you're saying, oh, if you look at LS, the position of that, or RS, or whatever you called it, as this number goes down, all the other numbers are constant. Therefore, this has to go down like that. I can follow along. So, uh, does that kind of make sense?
I guess so. I guess my question would be because I think on my exam I didn't explicitly write out R. Oh, I used R for the distance, and then I wrote that it was. I think it was like 5.0, but in part E I said that 5.0 equals R. I don't know if that would count.
Yeah, that, like I
Like
said,
it was.
if I can, it when I try to grade it, I mean, part of me looks at it knowing the answer and knowing, like, trying to figure out what you're doing so I can get you points. But another part of me also tries to look at it and think to myself, is this something easy to follow? Like, do I have to use my knowledge and my expertise in this subject to follow along what's going on, or could I give this to another student, essentially like a TA, and have them follow along and have it make sense? So, if it's the latter, then I usually grade for you, if that makes sense.
Okay, so I guess in future exams we should just write out every single variable before we plug in.
Yeah, that would be ideal, especially for that stuff. Just like I said, it just makes it easy for me to double check, especially when an issue comes up. Like I said, obviously, if you get the answer right, you you obviously know where the variables are, but the issue comes for a in case you're wrong. It's going to help me figure out where I can give you points. It's going to help me figure out, can I give this person majority points, or am I going to have to give them a zero because I can't really follow what's going on and their answer is clearly wrong. Uh, but it also helps for B, like I said, in the future, as these questions get more difficult, maybe not in this class, but maybe in the next class, when they become more difficult, it becomes really hard to follow your work the next day. I know plenty of times when I would answer questions, I would do my homework questions, and then I would look at my work the next day and think to myself, what did I even do? Like, what does any of this mean? So I want to try and instill that kind of habit of, okay, let's just write everything out, what's going on. It doesn't take that long. I'm not asking for like every in between step of, okay, now let's multiply these numbers. Okay, now let's add these numbers. But just something that says, okay, I started from here because this is my generic. Then I went to here. Then I went to here. And then now I got FY equals 10. You know, it's easy for me to follow what's going on rather than, starting from here and then getting to there. Because then I think, well, where did this equations come from? What are these numbers?
Okay, all right, thank you.
Uh, really quick, there was one example where someone actually in part A did some of the forces. Now, when I looked at their work, I could tell that they got the wrong answer, but it took me a while to figure out why they got the wrong answer because it was really hard for me to figure out what they're doing because there were so many steps being skipped that I didn't realize until a little bit later that the issue was that they weren't doing some of the torques, they're doing some of the forces, and was why the answer was wrong. And again, it made it really tough for me to figure out, like, how many points they should get versus someone who also got the wrong answer, but actually did attempt some of the torques. They just messed up with plugging in the sine or the angle, or they're in radians instead of degrees. Any other questions?
I have a few questions, like out of curiosity from the slides. That's all right.
Okay, sure.
Yeah. So I think one is the Doppler effect, and how like when an object approaches you, like the pitch appears higher.
Mhm.
Because like the like whatever the wavelength gets shorter. I was wondering because in real life, like when I'm listening to a police car comes toward me, the pitch changes and it gets like higher rather than staying constant. Um, so like does I'm just thinking like does angle have to do with anything with that?
Uh, Not really. So A lot of times that could just be because the car is there's a change. There is a change in the speed between you. A lot of times, like if a car passes by you, or like a, let's say, a police car or some sort of emergency car, on the one hand they could be accelerating, which like so they could be actually increasing their speed. Um, but also a lot of times you end up slowing down yourself, because of the emergency vehicle situation. So that could be one
Okay.
issue. The other thing is some people, I don't know how versed you are when it comes to musical talent, but
Mhm.
some people can't differentiate between pitch and loudness, in the sense that you might think that something is going becoming a higher pitch when it's just really getting louder.
Mhm. Oh, okay.
Um, yeah,
That makes
so
sense.
it could be something like that. The angles shouldn't be a factor though.
Okay. And I also have another question. Also, like, I don't know if this is a real concern, but it's like I kind of do play like the violin, and when I turn the peg, the string, and how like I feel like the string gets tighter, like there's more tension.
Hmm.
Um, does the does a what is it? The mass per unit length change
No,
because of
mass per
that?
unit length is
Um,
actually a constant. So mass per unit length is actually designed specifically for like string stuff, because when you when you're doing an experiment, and take you're dealing with string. So like for example, I remember doing experiments where we had to set up some sort of contraption where we had a string and then we would hang something on one end, and we would have to like change the length of the string, and it becomes really hard to measure the length because you need a little bit of overlap with the string to actually get it pulled and tight. So like how are you going to find the mass when some of that string is actually supposed to be useless? So you actually get the mass per unit
mhm.
length, which acts essentially like density. It's linear. It's also called linear density. So it's constant for the entire string. That way you could just measure the length of the string and you can automatically calculate what the mass is.
Okay, I see.
Yeah.
Thank you.
I don't know if they still have it, but I remember when I was going through Stony Brook, one of the lab courses would actually have strings, and they would have them actually labeled by their mass per unit length. So you would take a string, it had a mass per unit length, you'd set up the experiment, and then you could just measure the length and figure out what the mass was each time. Questions? I do want to remind you that for the next test, it's going to be another 2 questions. I know we're doing 3 topics, but as you should have noticed, all 3 of them are so closely related. It's really hard to tell where one unit stops and the other one begins. So uh, there's going to be parts of uh, one of the chapters. There's going to be parts in both questions. So you might have a question that's like one question that's question from the third video, one question from the fifth video, and then the fourth video kind of gets split between them, or something like that. So you're going to see parts from all 3 chapters mixed in the 2 questions. Um, but it's still going to be 2 questions, same length. Everything's pretty much the same setup.
I have a small question about something from the lecture 4 on wave motion. I don't know if you can pull up the thing on your end, but
Yeah.
uh, so on one of the example questions for standing waves and resonance, there's one that talks about 2 strings that would produce a standing wave, I think,
Hmm.
and I wasn't sure. I couldn't understand how to get the right answer, even though I was following the same steps. So I wasn't sure if you can quickly go over that or not.
You're talking so the 2 strings of equal linear density one.
Yeah.
All right. So one thing I want to point out is that a lot of the questions that I do in here, it's I'm trying to think of a good way of putting it. I kind of like set it up so that it's I kind of simplify it all into one. So it might be easier for you to kind of break it up into 2 different setups. Now, do you understand part A, like the answer that I got for part A? or do you want me
Yeah.
going over that?
I wasn't sure about B and C.
Okay. So, as I mentioned in part A, basically the key thing is that if we want to find the smallest frequency that fits on that will create a standing wave on both strings, then that means that the difference in their length has to fit half a wavelength. So that's what that first part of the equation is saying, that delta L equals half lambda, because the difference in their lengths has to fit half a wavelength. That's the only way that I could fit a standing wave in both strings.
Okay.
So
And then for the frequency calculation,
yeah,
uh, I kept getting the wrong answers. I wasn't sure if I was doing the right thing or not.
okay. So did you? I'm guessing you split up your calculation to find speed first, and then find the wavelength next, and then just divide them.
Yeah. So I found the speed, and then I plugged in for well, I think I actually yeah, I did like square root of the tension force over mass per unit length, and then
Okay.
over 2 times the difference in
Did you make sure to convert the mass per unit length?
uh to I converted to kilograms per meter.
Yeah. So the speed should have been 335.
Um, let me just- yeah, I had that.
Okay. And
Uh,
then so that's what you should have gone for the speed, 335. And then for the wavelength, so the difference in the length is zero point 0.1. Because we got to fit half a wave in there, the wavelength should be zero point 0.2. So it should be
uh,
335 divided by zero point 0.2.
yeah, so I think that's what I did, and then I ended up getting 1,677 hertz, but I think on the slide it said it was 530 hertz.
I'm looking at my slides and I'm getting, I see I wrote 1677. Now, I will point out,
Oh,
if it's on Ed Puzzle, there is a chance that I might have made a mistake initially, and I
also,
might
is
have.
it just like a different number
Yeah,
for?
so sometimes that happens because, like, I was gonna say I didn't want to re-record the entire video, uh, because in my defense, I only thought we were going to do this for a year. So I didn't
Yeah.
re-record it, but I did fix it on the slide. So the slide should be the most up-to-date thing. So if you do see something like that where you're getting a calculation, and even though you're doing the same work I'm doing, it's not getting you the same answer, you can ask me, but also just check the PowerPoint and the actual lecture slides to see if it got changed and updated. Um,
Oh,
yeah, because
okay.
a lot of so I'll just point out really quickly. A lot of times you'll see that where you'll see work that I'm doing and then the answer doesn't make sense, and a lot of that comes from the fact that when I do the equations, a lot of times I kind of like just copy the base section, like, so I don't have to redo the equation typesetting. But
Okay.
sometimes what happens is I get so focused on fixing the substitutions, I forget to actually fix the answer.
Okay. Yeah. I wasn't sure if I was just misunderstanding him.
No, like I said, if you a lot of times if you just like plug in what I like my right before I write the answer, like in this case the square root 810 yada yada, and you're not getting the same answer, then that's a mistake on my end.
Okay. Alright. And I just had one other question. I think so. I'm not sure if you mentioned this or not, or if this applies, but do you have like the cutoffs for the letter grades for this course, or is that not something
Yeah, I
that?
can actually post that because I think my letter grades not Yeah, I think my letter grades might seem a little bit different from other classes. Not purposefully, just because it's how the letters make the most sense. So even though A plus doesn't matter, usually A plus becomes a 99. Uh, A is usually around a 95. A minus is essentially a 90. Uh, B plus, I believe, is a. Hmm, I actually don't know what a B plus is. I think B is 80, 85. No, wait a minute.
Okay. So for like so it has to be above the cutoff for it to be the corresponding letter grade, right?
I think this is 85. Yeah, so what ends up happening is um, when I curve your grade, I curve to one of these. So I think that's 75. I think C plus is a 70. C is a 65. C minus is a 60. D is 55 and F is 50. I think this is what it is. So when I curve you guys, I curve you to the letter. So if you get like a certain percentage around the average, you can get curved to an A or a B or a C plus, whatever, and then you're given one this letter grade. You know, 75, 90, 95. At the end of the year, because I can't really do an average with a letter grade, so I need a number placeholder. So you get these at the end of the year. I combine these grades with your homework grades and all that stuff, and I do my average, and then there's a range between these that will actually get you to a certain level. So at the end of the year, it's going to be 70 and then like plus or minus two. So if
Oh,
you're
okay.
with yeah, so if you're like within 2 points of 70, then it goes to a C plus.
Okay. All right.
Yeah, hopefully that makes sense. I have the program. I set up the program so it kind of does the calculations automatic for me. And like I said, it makes sense on paper. You know, it works out for everything. So trust me on that end. Like I said though, it's important to remember that uh, the way everything is kind of set up, uh, after you get your first four test grades, your grade is for the most part gonna stay constant. Um, so when you get your like when you do the next two finals, or the last two exams, I guess, uh, there shouldn't be a wild change in your grade. Like if you're getting essentially in the 70s for every single test, then and you're doing all the homeworks, then you're pretty much most likely gonna get a 75. If you do really amazing on the final, maybe you might get into an 80, maybe. And if you do really really bad, then maybe it'll drop you back down to a 70. So like the whole point is like the way it's designed, the final's not a make it or break it type test. You're still going to be within the range of what you've been scoring on all the tests.
Okay. And then the final is not cumulative.
Not cumulative, no.
Okay.
It's only worth, and if you look at the percentage, it's not worth any like significantly more than the others. The only reason why it's worth more is just because it's a little bit longer.
Okay. All right. Thank you.
No problem.
Sorry about asking. You said that you can't post an answer key and you can't go over which exact question we got wrong on the exams. But are you able to meet one on one, or is that not possible?
If you're curious, you can always send a message, and if I get around to it, I can answer. I won't. I still won't go into like complete specifics, but I can kind of give you an idea of, which question the issue came from, or, if you were one of those people where you just weren't plugging in numbers or you just weren't showing enough work. I might say that comment like I couldn't really like, there wasn't enough work, so you kind of got penalized for that. But yeah, I'm not gonna go specific for questions.
Okay, because I just want to like know in case like for an exam if I make the same mistake or not.
No, yeah, I understand. It's just that, like I said, with the number of students, that if I were to meet with each and every single one of them, it could take a lot of time on my end. So that's why, unfortunately, I kind of have to leave it very, you know, open
Okay.
ended.
Okay. I might send you email later. Even just like something vague. I guess like if I didn't show enough work, that would be good feedback.
Yeah, no problem.
Okay. Thank you.
Anytime. Have a great day. Hey, how's it going?
Yeah. Okay, so I'm for the homework on chapter 15, I'm kind of confused of number 42 part C.
By any chance know what page it is in the textbook, like paper page?
No, I can't see the page number. I don't know why. It seems
Oh,
like the
are you
lower part of
using
the
the
paper.
online version?
Yeah, I couldn't find the book in library, so
All right, then can you actually see what the page is through the PDF?
just it's around 440 on the
Four
PDF.
440.
Yeah.
All right. Okay. Yeah, that was gonna take me a while. So what? It was 42. You said 42C.
Yeah. Yeah.
So basically, what you're gonna do here is trying to think of a good way to phrase this. Now, so in order for constructive interference to occur, that means that the amplitude is going to end up being at 2a, right?
Oh, yeah.
So because you have two different waves, each one has an amplitude of a. If they're constructively interfering, then they should end up making a combined amplitude of the sum of their max value. So a plus a. So what they want you to do is see if that's going to be true when phi is equal to 0 to pi 4 pi. Now there is this like sine term, but if you
Yeah.
remember that sine term really is just more the oscillation factor. If we want to see like what's happening to the amplitude, we look at what's going on in front of the sine term. So it's that 2a cosine phi over 2, which is actually why it's being um, grouped out of it.
Yeah.
So you just want to see if when phi is equal to 0, 2 pi, 4 pi, and so on, does that first part equal 2a? And then likewise, to find that where destructive interference occurs, again, because the amplitude becomes 0, or the difference between their max values, in this case it would be 0, we want to see is does the amplitude, that amplitude term in front, does that become 0 when phi is equal to essentially the pi, 3 pi's, basically all the odd pi's.
So destructive is looking for whether if it's 0.
Yeah. So you're basically just verifying that at those angles it's equal to 0. And the nice thing is that essentially once you figure out one or two, then you end up you don't have to prove every single one. So like you could do 0 and 2, and then you can kind of ignore the other ones since those are all essentially in phase with each
Excuse me, Mr. Clow.
other. Hey, what's up?
Yeah, and I'm not sure what to do with part D either for 42.
So what you're supposed to do is just basically plug in the what is what's the phi that they said? Pi over 2. You plug in pi
Yeah.
over 2, see what you get, and just think about what that actually means for the wave. So, like, what would the amplitude be? What direction is it going?
So, I mean, like in here, I don't know the K and the omega. So,
Yeah,
should
you're not going to end up with one answer. You're getting an equation.
oh, okay. So cosine of pi over 4 is just gonna be square root of 2 over 2, and then time 2 is just like eventually gonna become square root of 2a sign with the three things inside. So what's special about that?
So
You know,
okay, so they want you to try to explain what's going on with everything. So like first off, we have the amplitude, which you said was rad 2 times I.
the
So
square root of 2.
so that tells us what the amplitude of that wave's going to be. Uh, the Did anything change about the k and the omega, the kx term, the omega t?
No,
All right,
no.
so think about what is that telling us? Is it moving left or right? The I don't think the k really tells us anything about it. But the third term, the phase shift, does kind of tell us a little bit about whether or not like is this a wave that starts a sine?
No.
No, because that phase shift tells us that we're not starting as a pure sine curve. And in fact, we're also not starting as a pure cosine curve either. So we're basically starting somewhat shifted by whatever that is. Now,
Um. Oh, okay. Never mind.
yeah, and you could see that we're kind of like, yeah, I was going to say if you look at the original two waves, D1 and D2, D1
Yeah.
doesn't have a phase shift, but D2, if you used pi over 2 as the phase shift, then you can tell that like the phase shift that we have is kind of like in between those two waves.
Okay.
So basically, what they want you to do is once you have that equation, you want to kind of go from left to right and explain what is going on with each of the big terms.
Oh, so should I say like the K and the omega does not change?
Yeah, so you could
And
say it maintains the same size and direction as before, things like that.
for the phi is like shifted in between D1 and D2.
Yeah, pretty much halfway in between.
Okay. And the amplitude is like the amplitude is square root of 2 times D1 or D2.
Say that one more time.
So is the amplitude becoming only square root of 2 times the original
Yeah.
amplitude? Never mind. I don't think I have any other questions. I'm going off right now.
Okay, no problem.
Bye, Mr. Clown.
See you later.